with Bruce, sorry, I have stuff going on. With Bruce, we had a student that he just couldn't log into Canvas. And we're like, dude, we told you to like log into Canvas. And this was like the final. And it's like, gotta be able to log in. And so what I ended up doing was we just did a student view on my account and then had him do it on the student view. And I printed everything out as PDF and we got the grade and we were able to use.
But you never could get him to be able to log in again.
Well, no, it was just like we told all the students, make sure you can log in Canvas, and that's what I else did on the recording. It was like, make sure you can log in. Like, no, seriously, because when you come in, you gotta be able to log in. Because a lot of people just have it on the computer or on their phone, and
well, they'll be out the creek tonight.
Yeah.
And I'm sorry.
Well, normally what Bruce was like, make sure you can do it. Like spend the next, because you do a lecture beforehand. So it's like during that time, make sure you can log in Canvas. Double check, triple check.
Yeah. While I'm lecturing on that for section 6,
right.
You need to
make sure you can log in.
Yeah, and if you can.
Oh, whoops. This. Okay. Hey everyone, sorry about all the noise earlier. I didn't notice that we were recording already. So just want to make sure that, oh, actually.
Hello there, sir.
Hello.
Okay. Yeah, so hey everyone on the recording. So we had some questions on this particular question on the quiz. So yeah, I want to make sure that all of you have done the quiz. There are a few different versions, but length includes all characters. It's the number of characters there are. And so that includes the spaces. So not only are they the letters, but also the spaces. Anything that's a character, length is going to tell you how many there are. Also, if you wanted to do a substir, the first argument is the index. So we start at 0, so 0, 1, 2, 3, 4. And then you want to get 2 letters, so it would be 4, 2 would be how you get the substir of D. Hope that helps you all out.
Yeah.
Zoom recording. Okay, we're doing one of the. Okay, length minus what?
Minus 1.
Okay, and what's the length of?
What's the what?
So I can't just say length or length minus 1 because that doesn't mean anything. What's it the length of?
Length of first name?
Yes, right, a first name. So we do length dot, or we do first name dot length, and then it's a function. Great. So this is going to give us the index of the last letter, and then how many letters do we we want?
Last one.
So how many is that?
1.
Great.
So 1.
All right. Cool. And what do we have to have at the end of every line?
Semicolon.
All right. Cool. Okay. So right now, what is this program going to do?
Just print like last letter.
What is it going to print?
First name. C.
Yeah. Okay. So hopefully, let's run it and make sure that that's the case. It's always good to test your program. Cello world. All right, so we're good. So we printed out the C. It's doing exactly what we expected it to do. Oh, and for those of you that are recording that you sort of just randomly started in the middle of things, this is one of the last questions on the practice midterm that we're going through a solution for. Okay.
That else with the bracket won't interfere.
This?
Yeah. You should put like an else with an empty statement.
Right, it's nothing. Most of the time, if I have an empty else, I'll just put a semicolon there, just in case. Yeah, it means do nothing, but there's something inside of between these curly braces. Sometimes just having an empty set of curly braces like this can cause problems. It's dependent on the compiler. So most of the time, I'll just stick a semicolon in. Okay, great. So we did the first part. So what else? What else do we have to do in this case?
The second name.
Okay, and what are we doing with the second name?
Find out pronounced like as well.
Okay. So it's pretty much going to look just like this, right? Like what's going to be what's going to be different for the first letter and the second letter in the sense of the code part of it?
The name of the string.
Yeah. And that's all we need to change, right? And so what are we going to change it to?
Second name.
Exactly. So then we run it to make sure. And we got our cello world. Actually, let's get rid of that. So there we go. All right, so that's the first part. And actually, technically, if you read the question, you don't need to do this else part because they told us what the input would be. But we might as well do the else part. If you knew that your program was always going to be given this input, always, then you don't even need to have this if. You could just have this one line to see out. So literally, your answer could be one question. If you're being really nitpicky, your answer could be just one line, and that would be this one line. If you were guaranteed that your input was always going to be this. But let's be thorough. Let's actually do what probably the instructor intended us on doing. So now let's look at the else case. Where is my shutter? Okay. So what's that other case going to be?
Second name. The length of it.
Okay. So.
Oh, the valuation.
Right. Yeah. You just it's literally what's written here, and it actually doesn't say equal to. So we might have to have another case. So now let's split this up just so that we're thorough. Okay. Do you understand what I just did?
Yeah.
Yeah, because before this else covered if first name is greater than last name and if they're equal. Oh, oops, that's a minus equal. There we go. And so what I did was I split it up because this asks this tells us to do stuff. And so in the case, it doesn't tell us what to do if they're equal. So for this, we could literally just do nothing, and I think we're good. So in this case, we have an else. We don't do anything. We could also just get rid of this else because there's nothing there. But if, for example, we wanted to print out, hey, they're the same, we could do that right here in this else. Or print out an error of, oh, those two strings are the same. Okay, so for this else if, what do we do? Well, what does it tell us to do? So we finished this part. Now we're in this part. We're in this part right here. So what code are we going to write?
Oh, just the output.
No, what is the code that we're going to write to do this? So have we done this first one? The if second name is less than the first? Have we written that part?
Can you move it to the side?
Oh, sorry. I mean, yeah, it's going to be similar, but so okay. So print the last letter of second name followed by the last letter of first name. So which one did we print out first here? And then what was the second one printed out? Okay, what is this having us do for the second part? Yeah. So essentially, we should just be able to copy pasta this and then flip these guys. This guy with this guy. So now it's flipped. And then we might as well, because we're here, we can always show off. And always good to do. If you find yourself that in your entire program, you never print out a new line, but you print out stuff, you should always print a new line at the end of your program, because those smashes your prompt, where the thing that's asking for the next program to run, it sort of bleeds in your program. And so this is always good to do.
I'd like to ask you a question.
What's up?
So I think I was reading through these questions over and over the last few days, and what if we wanted to make a word that said, let's see, write a program that if first is less than second, output a single string with the last letter of the first name and then the last letter of the second name. What if we wanted to make it a string?
Oh, that's yeah.
And that changes it slightly from C out to just
right. So instead what we would do is that we would have like our string, we could call it output, and let's initialize it to an empty string, so you can never be too sure. And so then instead of using C, and let's say that we wanted to actually print out output at the end. So instead what we're going to do is we're going to concatenate them and then save them to a string. So let's just comment this out, comment this out, comment this out. So let's just do this part really easily. So output equals, they're the same. And then here we're going to say output equals, and so then this is going to be a char. And so let's see if we can concatenate chars. Because remember, chars are also integers, and so funky things happen. And so we want the first part, the first char, and we need the semicolon. So this is the first character, and then we want the second character. So we're good. So one of the things that you need to be careful with, though, is that substir, we're very fortunate. Substir in this context is giving us a string, versus if we accessed it this way,
What do you mean it's giving us a string?
the type. So if I say this, this is going to give me the first letter of first name. If I access it this way, so this is going to be one of the solutions that people are going to come up with, is if I want the last letter, just like how this substir does, you could also do this. This, so let's just say C out that. Let me just get rid of that. So right now, this output is going to be empty, and we get the letter C. This is the last letter. This is the last letter of first name, right? The issue with this is that this is a char. This isn't a string. Substir gives us a string. So we can add two strings together, but we can't add two chars together. So let me show you. If I do this and I say this plus this, and I try to print that out, I get a number. But down here, when we did the same thing, when we added the two things that we substirred together, right? When we did this, I'll just print them both out, we get our CH.
You can stick two strings together that are only one character.
They convert it to char.
No. So down here, these are two strings, and when you do a string plus a string, it just sticks them together. When you do a char plus a char, it takes the number value of the char, the character, and adds it together. And that's where this 134 is coming from. And so this is something to watch out for, because this happens all the time in people's code. Because when you print one at a time, right? If instead of this plus operation, if it's a C out, I can just do that, and I get CCH, right? Because it's the same letter.
Just be careful when you go at a string subscripting, you get a different result than subscript.
Right. So when you have the square brackets, when you're talking with a string, you're going to get one character. When you're using substring, you get a string.
Which may be double quotes.
Which is or empty.
Or empty.
Like this, it's an empty string. Yeah. So just something to watch out for, because that can mess you up. Is that clear? I'm hoping. Yeah.
If you always use substr when they ask you to get a substring or something, or take a few characters out of it, always use substring. Then you won't have a problem.
But know that this syntax, the square, if somebody asks you for a char and save it as a char, then the square bracket is going to be useful.
One character char and a one character string
Right.
are not the same.
They are not the same. Yeah. The literals of actually that's not G shell. IPython will tell me it's the same. Yeah, so that's you comparing like A versus A. Which of these is the character?
First A.
Yeah, and then the second one is what?
Straight.
Yeah, exactly. And so are these equal? Right. It's gonna be grumpy. This is Java, but the same thing would happen in C++. Is that it would not be happy. You can't compare a char to a string. Okay, cool. So cool, good. Or is there anything else that's with this example answer?
No, I got it. Although I think the answer for the I think there's 2 lines or 3 lines.
Well, yeah, technically, if you want to get really nitpicky, the actual answer, you could get rid of all of this. That's the answer. That's one line. Yeah. So technically,
actually used like a third.
yeah, right. It made another string because that was probably a question. Yeah. So like for example, as I mentioned, if you're guaranteed that input of those 2 strings, you only need to have one C out. You don't need to have everything else.
Carter was just reviewing the practice today, and answering some questions that one of the students had. So if you have any questions on the practice exam, ask Carter. He's recording this session for you.
Yeah. And it's just me, so like if you ask the question, I'm gonna walk over the computer and repeat it. So one of the most important things to make sure that you can do is I would pull up these computers and make sure that you can log into Canvas. Because if you can't do that for the midterm, you're gonna get a 0 on the midterm. So yeah, make sure that you can pop these up, log into the computers, log into Canvas. The login for the computers is this right here. So student and then funny Cabrillo. We call it funny Cabrillo, it's a capital C and a 1s instead of capitals. There's actually a reason we write that all the way on that side of the board, is that way when we say it, it doesn't go on the recording so the robots can't hear us. Because we use that password. Honestly, you're like if you're in the CIS area and you come upon a machine, you can probably log in with those credentials.
You can have a STEM center.
Yeah, in the sense of like you get in, like even if you get through the lock in the lab, a lot of the computers in the lab have the same password. Because we're here, we teach security classes.
There was another thing also with some problems.
Yeah.
The adding the chars, like A plus B plus C.
Yes.
And then converting them to like ints, I guess.
Yeah. So chars.
Make them capitalized or not.
Right. So if you look at the ASCII table, you'll see that the uppercase and lowercase are exactly 32. The integer of 32 apart from each other. So, and we can see that. I'm lazy, so I'm just going to use the J shell. But yeah, so if I take like a, lowercase a, and I subtract it by uppercase a, I get 32. Let me make that big enough. And so the idea is that I should be able to take uppercase a and just add 32. Here's the fun thing. It's going to stay as an int. And so we have to cast. Remember, that's where we use these guys. We're going to have to cast all of this back. Because chars and ints are essentially the same thing. It's just that you have to tell it, hey, no, I actually want that integer as a char. And so what you could do is that if you wanted to make sure that the letter that you got from the user was always uppercase, right? You could have an if. You could have an if condition, check the values to see if it's within that range. You could literally just say like, is it between uppercase A and lowercase z? Or you could type in the number. The number is a little bit harder to understand when you're reading the code, but yeah. So like a lot of times what I'll do is that if I'm not sure that whoever's looking at my code will understand, I'll actually show them this top line. Like I'll store this top line somewhere in my code so that I'm like, look, this is the distance between uppercase and lowercase letters. So then I'll use that.
It would be like char D minus char A plus A uppercase, for example. Like in the
Right. So the issue is that if you add two chars together, if you add two chars together, you're gonna get something that's probably outside the ASCII table. Because essentially, imagine that you're adding those two integers up, and then you're looking for that listing in the ASCII table.
That's what the question was asking. That's what my confusion was. How happens when you loop?
It doesn't loop. You exceed it, and you go out into this unknown space, where a modern compiler is going to be helpful to us, helpful, that's in quotes, and it's going to go into the UTF-8 space, which is where your emojis are, where all your really weird characters are. This is not a stable state in the sense that your program is going to start doing weird things. So don't expect that kind of behavior to work properly. So you should stay within the ASCII table for your programs. Otherwise, that means bears. So able to log in, Candace?
It's loading.
Okay, cool. And then you both have a chance to go through the practice midterm. And do you have any questions on the practice midterm?
Notes from the textbook that were a little confusing to me.
Okay.
I'll just
Great. We'll go over that.
You come to the right place.
Carter, I just don't get how, like, for example, lowercase d minus lowercase a plus uppercase a equals uppercase d.
Oh, okay. So let's look at the integers of them. So we have so uppercase a,
Lowercase d
or lowercase d
minus lowercase a plus uppercase a.
Oh, okay.
And chars.
Oh, sorry, chars. Yeah, okay. So here's what happens. So we get the distance between D and A. Right, so let's do that first part. Let's get that distance. So the distance between them is 3. So if I took just A and added 3, what do I get?
D.
Exactly.
So this is the distance between them, right? D is a little bit bigger than A by 3. And then if we just take uppercase A and we say, give me 3 more from here, then we get our uppercase D.
But one of the peculiarities of C and C++ is that these single chars can be numeric or a printable character,
And the
depending
same,
on context.
and the same is with Java, because chars are still sort of primitive. There's primitive, I mean, there is primitive as I guess they get. Not the character. Character is different than char.
Yeah.
That's one of the fun things. To tiptoe around the words within a Java. Are you able to log in the Canvas and all that?
I haven't sat at this computer yet.
Okay, it's worth a try.
But I'll try.
It's worth a try.
Yeah.
Yeah,
Yeah,
we had a student,
yeah,
we had
yeah.
a student last semester that they couldn't log in and it was bad news. Yeah, so any questions on the midterm or on the questions that were in the discussion?
Didn't have a question on the back before.
Oh, on the homework?
Yeah.
Oh, okay. Yeah, I guess we could do that.
That'd be tomorrow.
I don't know the due dates. Look at
Oh,
Canvas.
tomorrow. Labs are always due on the Thursday. We decided last time that they'll always be due on Thursday after the class. So you get one more chance to ask us questions on Wednesday afternoon. And Wednesday now.
So lab 4, you say? Okay.
A4.
Okay. Where?
It says it's got the 3 exercises, and I've done the first 2, and I think. Okay, well, one of them was for the second one, the days of the month. Is it gonna matter? Like, we have to prompt like the user to enter values for, I guess, for both of them.
Huh?
And are we gonna do markdown if we like don't know how to make it so that if the I'll ask it about the first one, so that's actually more of an issue. Basically, if the user enters something like nonsensical, like the code will still work and it'll say something like it'll print like a certain time first or whatever. Like, do we have to find a way to make it so that they can only enter military time?
Or Zulu time? I mean, for the most part, I think that you're only going to give them valid input.
Yeah.
So I mean, we've learned with like a do while loop that we can force a user to give us valid input. But for these assignments, you're always going to be given valid input. Next semester, you'll be given bad input all the time. But I mean, you're going to be pretty safe. Like somebody's not going to like take in a string or anything. But you should be able to check like they entered in 9. That 9 is whatever they entered in is between these values. You should be able to.
With the days of the month, I was able to do an identity while loop to make so they get valid input, but for the time one,
The first one.
Oh, for the first one? Right, so that these,
I did that as a string actually. I used strings to get like substrings because it wants you, if you read the textbook question, it wants you to like read the first 2 numbers as like the hour and the second 2 numbers as the.
That's pretty much what you're going to have to do. You work with it as a string in the beginning, and then you can convert it to an integer later, or just keep it as a string the whole time. So that's fine.
It's fine.
Yeah, that's fine.
Even
You're gonna
though
be given-
it's possible to enter A, B, C, D. and
Right.
word.
You're going to be given valid input for this class.
Yeah, it'll be for different. In the next class or 2, we are gonna cover broken CN. So if I give you something that you're looking for something and I give you something completely different, it'll clunk up the CN buffer. And we'll teach you how to clear that out and reset C and be good. Go back and ask them for a valid input. So we'll learn to do that.
Right now, essentially, the only thing is that you can validate is like for the months, is they give you a valid month, but nothing more than that is expected from them.
I did with the days of the month when I did the do while loop.
Yeah.
Make sure it's between 1 and 12.
Including 1 and 12.
I did enter when I was doing like the testing. I did enter like an R or something.
Yeah, that's gonna
and
mess
that
it
sent it into like an infinite loop.
Right.
And why did that? Why that?
Because essentially it's looking for a number, and that R is going to be processed as a string, and so it keeps looking for you to give it a number, but you mess up the buffer. We're going to learn about that later. Like, I don't mean to be evasive, but I want Rod to give you some of that, and then I'll follow up.
We are
And then I'll follow
discuss
up
that in time, like the next chapter. So you just within a week, you're going to find out how to handle it.
And then I'll have a session 4 specific to that. What's up?
So we don't have to know the sim fail.
Right now, yeah.
Okay. So 3.8, just like disregard that.
Is that a section?
Yeah. that
Yeah,
was
so
what I-
we're gonna use that over the next 2 weeks.
It looks like tonight we're going to talk about it.
Or tonight. Cool.
Yes.
Oh,
we'll learn
excellent.
How to do CN corrections tonight.
Wow. Okay. On a fast track. Cool. Yeah. So besides
Add that to your-
that, was there any other questions for this exercise? So sounds like you're solid then. Cool. Okay. And then you said you had written down some questions in your notes.
There was one part, I can't remember where it was, but it was basically saying like another way of notating something. Like a different notation or something, but I'm trying to find
You mean like a comment notation or?
it. It was like a type of loop notation.
While, do while, and while loop, and then do while.
Yeah, it was fun.
Of course.
I just like, I can't remember because I had come home really late last night from work and I was like trying to review it. And then
Yeah,
it was just right now,
so-
like,
so essentially-
my brain.
In this class, we're only going to be really working with the 3 loop types: the while loop, the do while loop, and the for loop.
Okay, so then the other notation we don't really have.
Yeah.
And then and same for like case switch. We're not going to be doing any case switch in this class. We're just going to have a big FL slider.
Let's see if we can find what you're talking about in chapter 4.
Yeah.
Because I read chapter 4, I'll look at it.
Unless there's something about the blue variables and then some variables.
I'm trying to figure out what you saw.
The Boolean truth table confused me too.
Oh yeah. Okay. We can do that. We can definitely do that.
Tables?
Yeah. So grab a pen. Okay, so let's go to a barbecue. So if we're at a barbecue and the guy comes up to you and asks you, do you want a hamburger and a hot dog? And you say yes. And then he only gives you one of them. You're gonna be pissed off, right?
Yeah.
Because he didn't give you both. Because and means both. But if the guy asks you, do you want a hamburger or a hot dog, and they give you one of them, you're happy. And if they give you both of them, you're like, sweet. Wow, this is great barbecue. So and or is pretty much how it's the same that we use in English. So if we have something that's true, and then we have something that's true, then what's this whole thing going to become? True and true is what? True, right? So this can be true. So essentially, instead of me writing lots of lines, you can make a truth table. where you essentially have like let's say that this is A and B, and then let's make like a truth table for the whole thing. So we have our A, we have our B, and then we have like our output, which we'll just call C because we're lazy. And so we go through counting order, and the operation, actually, let's just do this. A and then B, that way we don't need to C. So we go in counting order, so it's, would you prefer that I use zeros and ones or false and trues?
False and true.
Okay, so we start false, 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 true, true, false, true, true. And this would just be 0, 0, 0, 1, 1, 0, 1, 1. So what's false and false?
False.
False and true,
False.
true and false,
False.
and true and true. Exactly. So there we go. We've now made our truth table for the and operator.
That makes a lot more sense because I was looking at it and I was like, this makes no sense to me.
Did you want me to do or you good?
I think the or makes sense to me, but the exclamation point.
Oh, yes. Okay. So the bang or the not. So so I can erase this? Okay. So the and or are binary operators. They work with two things, by two. The bang or not is a unary operator. Uni, like unicorn, is one, there's one. Horn. So it's so this gets stuck on the front of whatever you're changing. So what's not true? That. Yeah. So essentially what we would do is we would just say like if we were to make a truth table of this, it would just have our A and then our not A. And so we have our true and actually we're counting. Sorry, I took a symbology class and they flipped everything's backwards. Everything's backwards, it drives me nuts.
It's like an inverse, and so like if A is false, then exclamation A is true.
Yeah, exactly. Yeah, it flips whatever it is to the opposite state, and because these are booleans, they don't hold true or false at 1 and 0. So yeah. No, it drives me nuts. So the computer scientists do it one way, and then the philosophy people do it a whole other way. And the philosophy people throw serious shade at like the computer scientists, and I throw it right back to them because I'm there. They do all of these tables upside down, which drives me bonkers.
You know too much.
I know too much. Yeah, actually, that's what the instructor told me. So cool.
I think I may have found your loop problem also. Maybe try looking at the top of page 147. There's something really strange there. But use loops, use for loops for their intended purpose. That one.
You can.
Reading that, I was like,
I've seen some.
You can put anything in those three expressions that you want, but it makes no sense. So don't ever do that. If you want weird looping conditions, use while loops. So they've done a thing here, for everybody.
Yeah. Essentially, that right here, you have something that's user dependent.
You
Don't
don't
do
see
that.
in X as the end, and the beginning condition is C out inputs in double quotes. It's just
No.
don't do that.
So
that's what they-
yeah, so a for loop's usage is right here, this very moment, right before it starts up. You know exactly how many times the for loop is going to run. A do while loop, you know that you're going to run at least once, and that it's dependent on the user or some other input or data that will decide whether or not you keep going. A while loop, you don't know if you're going to run once. You might never run based on the condition. So these have very distinct uses. But a for loop could be just as easily made into a while loop, right? That you just have an int I equals 0 right above the while loop, and then right at the end of the while loop you have the t++. What was happening is that a lot of people have these while loops that
they had all of that, and so that's why they invented the for loop. The for loop is a while loop, except it has the benefit that when this bottom curly brace hits and you're done with the for loop, I goes away. I is no longer around. The issue with this while loop is T is still around. This condition that this while loop uses for T, it still sticks around later in your program. And maybe you want that, or maybe you don't want that. I like to be able to just dump for loops all over the place and not be concerned with having to change this variable all the time. So it's very useful because I can have a for loop, another for loop right below, and I don't have to change this, I don't have to change this. The only thing that I might be changing is this. As was the while loop, where the while loop, I'm like, oh, what, did I already use that variable? And then now I have to start naming them something useful.
So in a for loop, the order would be like initializing the variable.
Yeah.
And then basically what would be in the while loop. Like the while
This is inside the while loop. This line here and this. And it only runs if this is true.
Okay.
So this happens once at the beginning of the for loop. Then this happens to decide whether or not the for loop runs. So it runs before the while loop starts up. And then this happens at the end. Essentially imagine that this is just like this. It's stuck, it's somewhere, it's right here, it's right before this bottom curly boy happens. That this plus happens at the end of the for loop. It runs every time. And then this, we check this. If it's still true, then we run it again. We increment and we keep going until this is false. And then we don't do this or this, we just drop out. Okay. We escape. Oh.
in that for loop.
Yeah.
Would it just keep going?
This for loop? Well, what's it dependent on?
Oh, so once it hits age, then it
Mhm.
would stop.
Yeah, exactly. Because they're equal, this is false, and we drop out.
What if you enter age minus 1? How many times would the for loop take place? This to be bizarre.
So what is 0? Is 0 smaller than minus 1?
And it would never happen.
Right, it would never happen.
Yeah.
It would be false. So if you have a negative age, then this still works. Fine.
If you just don't do the loop.
You just don't do the loop. If you're not born yet, you can't say, are we there yet? If you're zero years old, you also cannot ask if you are there yet. But if you're 1 year old, then 1 is greater than 0. Are we there yet? Once. If you're 2 years old, say, are we there yet? Are we there yet? The older you get, the more clever you get at saying, are we there yet? But you still ask. Maybe that we take longer road trips. I'm not sure.
And is this a working book that's up there? So I'm just trying
Yeah,
to.
this is working code, and this is on my GitHub.
Okay.
So the link that I repeatedly send out to everyone, this is on that site.
Yeah, I have that bookmarked on my laptop, but
Cool.
I'm just trying to figure out like when the user would input age.
Right here.
So there's no like prompt that says it just like
Prompts
kind
are
of
always
pops up
good.
and then they press.
The program just stops until they type in an age. So we might say, see out how old are you? That would be a good thing to do.
Okay.
You should always do that. Right now I'm being rude. I'm not asking the user for input. The program just stopped and they have no idea why the program stopped.
And can you briefly go over like binary numbers? Just, like,
Binary numbers? Yeah, sure.
like,
Okay.
the decimal points for it.
Well, no decimals and binary.
Because on the practice midterm, one of the questions says to input
Oh, yeah.
like 1
0,
0
1,
0
1,
1
1.
decimal.
Oh, yeah, decimal is base 10.
Okay.
Sorry, it's not like the decimal point. It's decimal is base 10, which is the number system we use for most things. Okay, so so let's do that. So essentially, each position is 2 to the power of something. So 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. So we're only going to deal with 4 bits. What's 2 to the 0?
0 1
1. 2 to the 1?
2
2 to 2? And then 2 to 3. Yeah, okay. So essentially what happens is that we're essentially just going to, this is for helping us. So if I have something that is the number 0 in decimal, then in binary, it's going to be 0, 0, 0, 0. If I have the number 1 in binary, it's 1. 1, 0, 0, 0. So this is equal to the decimal of 0. This is equal to the decimal of 1. Okay, now let's mix it up. So now let's say that I want the number 10. And the way that you tend to work, if you're human doing this, is you work this way. So we have the number 10 in decimal, and we're going to say, hey, is how many times does 8 go into 10? How many times does 8 go into 10? Right, 1. What are we left over with?
2.
So we have 2. Does 4 go into 2? Does 2 go into 2?
Yes.
How many times? 1, right? And then what are we left over after we do this?
0.
0. Does 1 go into 0? Right. So now we have our decimal of 10. And so then you do the inverse to the other way, is that if I want to get the decimal of 10, I can look at this. This is the 8th place. So I say 8 plus 2. And so then I'm able to get my 10 back.
Can we do that for a 64-bit binary?
Yeah, let's just keep going. No, careful. If you're in CS21, you ask Steve to do that. He's like, yeah, we'll just fill up the whole board. Oh, no.
Sorry.
I pretty much stop at 8 bits. You know, everything besides that, I start using the computer to do it for me.
I'll behave.
Yeah.
So the difference is 4 bits.
Huh?
What would be the difference in 6 bits?
It's longer. It's just so this is 4 bits.
But just be like 0, 0.
It's just lots of zeros. Yeah. So if we were doing 0, 1, and 10, right, it would just be a ton of zeros. It would be 60 zeros going that way. But the front part would be exactly the same. But if you were some smart ass who would, hey, what's 1024? I'll be like, it's like right here. Okay. But yeah, the neat thing is that everything's a power of 2. And so if for some reason you can't remember the next one's 16, you just take this and multiply it by 2, and you've got your 16.
There are a couple of magic numbers out there in the world that every programmer ought to know.
Right, you should know
4 bits
1,000.
of 1 should be 15, and 8 bits of 1 is 255. And everybody should know all 8 bits all on is 255, regardless of this. We'll never give you more than 4 bits in here.
Right, yeah, 4 bits is.
We covered that in CS1. So we assume everybody took CS1, but most people didn't.
Oh,
So it was a wonderful class with an absolute.
you get to watch Triumph of the Nerds. What other class do you get to like hang out and watch movies?
I know.
Yeah. So did you want any other numbers, or is this sufficient?
That's good.
Okay, cool. And everyone else is solid.
Yep.
Fantastic. Okay, cool. Yeah. So we got our decimal binary, our truth giveaways, our loops. Any other questions before we go into our activity?
I have one.
Yes.
Can you do like an example of the asterisk problem? You know, you have to make a triangle.
Okay. You want a right triangle, or what kind of triangle do you want?
Or just triangle, it's fine.
You want a triangle like this, or do you want a triangle like this?
It'll be like
This is much easier to do in code. In code, this is much easier to do than this. It's like an extra like 2 lines to do it like this. This one? Okay. So essentially, we know that throughout the loop, we're always going to print an asterisk here, and that we're only going to print out 1 asterisk per an iteration of the loop, and it's going to be dependent on the loop. So a for loop is a fantastic thing, because we know before we start printing the triangle how many times we're going to run the loop. So instead here, instead of asking for age, we would ask for the height of the triangle. And that then what we would do is that we would then have another loop inside of here that would print out the number of asterisks based on I.
So let's just do that. So I'm going to be lazy. I'm just going to grab this. And that. And I want a new instance of repellent. Actually, let's just copy this guy. So let's do. Okay. Okay, great. So, sorry, I realized that you couldn't see that. There we go. Okay, so I just took the loop example and then I changed it to say height. So we're going to ask. We should probably ask the user for input. How high of a triangle do you want? Okay. So we're always going to print out the asterisk because we need this right here. So let's write the code to do that.
For these triangles, you have to do that in the main, the argument C char.
No, we're not going to. No, not in this class. Because we haven't been shown how to convert arrays of character arrays into integers.
So we
don't know how to do that yet.
Leave the main empty.
This could be empty. It doesn't matter. I just do it because it's a force of habit from coding in C. Okay, so we ask the user, how high of a triangle we want. They enter in a number, and we want to print out that border. So let's just do our cout of our star, and it doesn't matter. It could be just that, and then that's it. The end of this loop, we also know that we need to print out an end line, and that somewhere in between here is where we're going to print out the star at that distance. And then also let's, based on the height, we can also at the end of the for loop just do another for loop where we print out all those bottom stars. So right now, this should just print out on each of them the line, and then this here should print out and that's A and not a star. Keep doing that. And then this should print out the bottom line of the triangle. So let's make sure that that actually works. How long? So we're going to say 10, and so good. You have that's what we got. We got this and then this. Now we got to print. Now we got to print this. And so I left that gap in the code because right here is where we're going to do that. So what do you think we're going to do right here? So what do we need to do? So we've got the L of the triangle. Now we got to do this part of the triangle. So the number of spaces. And so how many spaces do we have a number, an integer perhaps that tells us how many spaces we're going to print out?
The line number I.
High is but high is the end result.
So at the first, let's say the first iteration of the loop.
No, I mean I.
Oh, I. Yes.
Yeah, absolutely, I. And so we're going to have another loop that's going to be, its condition is going to be in regards to I. So most of the time we're just going to call this J. And it's while I is smaller than J. Or sorry, J is smaller than I. There we go. And then J plus plus. And so what are we going to do in here?
So
Wait, what is J?
J is our second loop. So I is the number of spaces that we want to print out. But we can't just say print out this many spaces. We have to do another loop where we print out one space at a time. And so J is the current space that we've printed. Right? So what do we want to do? What do we want to print out here in this loop?
J plus plus.
What do we want to print out?
The space.
The space.
Okay, great. And then we might as well, after we're done, print out that star. And what's the flaw right now?
What's going to happen right now? There's a problem, right? Because what happens if we're at the top of the triangle the first time this runs? Do we get a nice pointy triangle?
We have space.
Well, no. So, okay, the first time this runs, 0, so this is going to be 0. So this for loop doesn't run, right? Because it's 0 less than 0. Is 0 less than 0? No, so this is false. So this for loop never runs. So what prints out? When this the first time this for loop runs, what prints out?
Just the asterisk.
1.
No, I just thought. No, we just found one.
It prints out 2 stars.
Oh, yeah.
Because it prints this star out and this star. And then a new line.
Why is it the second star?
Because they're in this for loop. This for loop is just the C out of the space. So it does this. This is false, so it doesn't do this, and then it does this. So we get 2 stars and an end line.
So what we can do is we could just be lazy and we could just say, you know what? We're always going to just print, we're just going to hard code that first star. That way we get a nice pointy thing.
What will happen if we hide 0? Print 1 still.
Right, so that's the fun.
We get that 1 star.
So we could test for that. There's lots of things that we could do.
I noticed that I'm missing sort of a gap here, so I might
Have to add one there. But yeah, so that's pretty much, that's how I would go about if I was under a time crunch. Cool.
And essentially what I would do is if I needed to make it like this, is that I would divide it by this space. I would divide I by 2. And that would tell me how many spaces.
Dividing I by 2.
Yeah. Because that tells me the middle position. And I would be based on height, so these would be flipped.
Because I would want the middle position for them, and then I would go out from the middle position. I'd say
whatever the middle is, -1 and +1, and then I would use I. Right, when I is 2, then it's 2 spaces away. So on the first one, it's the middle, and the second one, it's plus and -1, and then on the second one, it's plus and -2, 3, 4, 5 until you're done. So first you figure out the middle. So essentially you would take height, divided by 2. That tells you the center of the triangle. Right? Then if it's an odd number, well then you add 1, or you tell the user, no, I only take even numbers. Yeah, so some people will tack on at the end. If you take 12J, this is a problem that the students have with one of their assignments. That's just that you could just tack 1 on at the end or whatnot, because you want to get an integer, or your whole thing just shifts a little. With really big numbers, because they deal with like thousands, like triangles that are 1,000 by 1,000, you don't really see it with your eyeballs. Yeah, so you take height divided by 2, and then because it's an integer, you get an integer result, and that's the position of the middle of the middle one. So just like how we printed this out here, we essentially have a for loop where we print that many spaces out when we go out, and then what we do is for the second line, we print out. We have I, again, is going to be in the for loop. We have I is going to keep track of your position. And you essentially are going to keep going. You're going to have an if statement that says, if I is height divided by 2 minus 1, or minus I. Maybe let's use I for, sorry, I'm writing the program in my head. And I keep rewriting the program because I find a better way of doing it. Okay, we're going to have 2 for loops. We have an I that's going to keep track of what row we're on, and then we're going to have a J, and that's going to keep track of where we are this way. Just like how we did it here. And so we're going to have inside of here, we're going to say if J is equal to height divided by 2 minus I. That's going to give us this side of the triangle. It's going to say, yes, we are here on this part, and then you print out the star. Else, print out your space. And you keep going until you have your else if you're here. And that's going to be if J is equal to height divided by 2 plus I. And then there you go. You've got your triangle.
Cool. Okay. Any other questions before we go on to our game? Okay. One last question. All right.
Return 0. When should we use it or not? Like
Always return 0. Unless your program crashes spectacularly. If you know that your program is going to catch fire and going to burn, the whole world's going to come to an end, then yeah, you change to 0. 0 tells the operating system that your program completed successfully. If it's anything besides a 0, the program terminated in a bad way. And so what people will do is in this comment block up top, notice how I say return 0 completed successfully. If, for example, your program takes user input and the user is being mean and they give you something that you can't deal with, you could either print out saying like, hey bro, that wasn't cool, and you keep them stuck forever. The issue about that is sometimes your program isn't being run by a real human. Sometimes it's being run by a robot. And it's really hard for the robot to see your printout saying, hey, that's not cool, bro, and then asking them for input again. So typically most programs, they return a non-zero when something bad happens. And that tells the robot, oh, I must have done something incorrectly. And then it will send an email to a user or something and say, hey, something's up.
Yeah, so 0, everything was kosher, everything happened good. Non-zeros are bad. For the most part, in this class and even in your next class, you're only going to return 0. Because in this class, you're essentially going to trap the user until they give you valid input. But when you're in the real world and programming on real devices, you're gonna see some kind of variable here. So that happens all the time.
Do you use parentheses or just turn zeros?
In C++, you use parentheses. Same thing in Java. If you are in Bash or in Python, you don't use these parentheses because they have a different meaning.
I haven't seen those parentheses before.
Probably use parentheses. Use the parentheses. The more complex, because you need to group what you're returning. Right now, you're getting away with it because we're working in main right now, but later on we're going to be working outside of main and with we're going to make our own functions. And this return is a keyword that says give back to whoever called me some stuff. And if you don't do this, bad things are going to happen in C++. So do it like that. If you don't believe me, in 2 weeks you'll believe me.
Okay, cool, good, all right. Let's do some Fizzbuzz. So have any of you ever played Fizzbuzz? Fantastic. This is a learning opportunity.
So Fizzbuzz is a game you would play on the playground when you're really bored. For some reason, they didn't give you a nice bouncy ball or some jump rope. It also makes a really good improv game. It's a counting game where essentially people take turns counting. The trick, though, is that anything that's a multiple of 3, you say fizz, and anything that's a multiple of 5, you say buzz. So 1, 2, fizz, 4, buzz, so on and so forth. It gets old really quick when you're playing with humans. I mean, I've seen people like enjoy the hell out of this. I don't know why, but this makes for a really interesting program. Because, for example, what should we print out when the number is 15? Yeah, exactly. And so I would encourage you. So I have pens here, or you can do it on your own computer. We have plenty of whiteboard space. Write this program. So maybe prompt the user for how many do we want to count to, and then print out Fizzbuzz or the number. Yeah. Oh, and as just a reminder, this might be useful, just as a reminder. If not, figure it out.
I have no idea.
You have no idea? Okay, so can you make a for loop that prints out all of the numbers? So if you types in 20, can you print out 1 through 20? And then the number, or the number. So for example, I'm expecting 1, 2, fizz, 4, buzz. As like output of the program.
Fizz, 7.
Right, yeah. Show off. You
I'm
can do
sorry.
division. You can do division.
I'm sorry.
So can you make a for loop that prints out all the numbers between what the user typed in and between 0 and what the user typed in.
So how do we take user input?
Can you user put negative numbers?
Huh?
0 or negative? Is it?
Let's say the user's going to enter in valid input. And even if they entered in negative numbers, it's not going to matter. The way that we're going to write the program, it's going to be fine. If they enter in negative 20, it's not going to run because of how a for loop works. You don't know? So how are we going to take user input? How do we get a number from the user?
Maybe for number equals 0, I guess.
Okay, so let's start. How do we take user input?
Cn.
Okay, Cn. So Cn, and then how do we get it?
Number or whatever.
Okay, so num.
Yeah.
But what? So we're missing some stuff. So num is not declared in the scope.
Bigger, I mean the bigger.
Oh, okay, so operators are good. So and which actually, I guess which way does it go? Which way is it pointing?
It's pointing the.
Is it going this way, or is it going this way?
That way. Last one.
This one? Yeah. So it's pointing. The point is going where the data is. So it's eating stuff from Cn and it's feeding it to num. Okay. The code does not compile. Num is out of scope. So maybe we make a num. Okay. So we got a num. So now what do we do?
Now we do like a 4.
Okay. So what are we foring?
Number int num. Oh well, you already did that. So maybe initialize num.
It's initialized by the user. I mean, we could initialize num. There we go. Happy?
You want smaller? I don't know, smaller than 20. You said.
So what is the first thing that we write? What is the first part of the for loop?
I thought it was the initial value. They start counting from.
Okay, cool. So what am I going to write right here?
The initial value. I don't know.
The initial value. I don't think that works. What am I going to write right here?
Num equals 0.
Then we just lost whatever the user typed in. The user just typed in stuff right here.
Just num, I guess. I don't know.
So we need to count to whatever they typed in. So if I say, could you count to 4 for me? What is the first thing you're going to say?
1,
Okay, and what's after that?
2, 3, 4.
Great, cool. So, and how did you do that?
I started at 1.
You started at 1. Okay. So, and then you kept going until you hit what?
4.
Yeah. So you kept 4. So you kept 4 lurking around somewhere. You had a variable. Let's call it num. It's your 4. And then you had something else to keep track of where you were, right?
The previous number.
Or yeah, the number that you had said. So.
Number plus plus.
No, we're not changing number.
I don't know.
You don't know? Okay. So with the for loop, what does the syntax look like normally, just generically?
The 3 parts for the.
Right. Yeah. What is the first part?
I thought it was the initial first value.
So you're right. So it's going to be the first value. So we essentially create. So we create a variable that's going to keep track of where we're at. So num we're reserving because that's our goal,
Our goal is to get to null. So normally a for loop looks something like this. You have your int I, or whatever it is, and then we're going to set it to 0. This gets run at the beginning of the for loop, and that's it. After the for loop is running, it doesn't happen again. So the first part, and then we have our condition for whether or not our while loop runs. So how many times? So what are our conditions going to be for this for loop?
Smaller than 20.
What's smaller than 20?
I.
And where does 20 come from?
You say 21st.
Yeah, but let's say that that's what the user types in. User types in 20. So where are we storing 20?
No, what do you want to select? You want 21st numbers or you going back?
Up to 20. So from 0 to 20 or from 1 to 20, whatever. Probably 1 because these are elementary school kids. They don't know about the number 0 yet. Have you ever played Fizzbuzz? No?
No.
It's a fun game to play on the playground. So essentially the game plays like you sit in a circle with a lot of people and they take turns counting. And so the first person says 1, the second person says 2, the third person says fizz, fourth person says 4, the fifth person says buzz, and so on and so forth.
Is it particular has to be 4 or has to be 5 is fizz?
Yeah, so fizz is numbers that are divisible by 3, and buzz are numbers divisible by 5. Okay. So imagine that we were just counting 1 through 20. Except anything that's divisible by 3, we say fizz. And anything that's divisible by 5, we say buzz.
So I'll be the fizz, and you can be the buzz, and let's start counting. 1, and you can say 2. Fizz, buzz, fizz.
So the idea is to grab a pen and maybe write a program to do this for us. Because for us, when we start getting in like the billions, it's really hard for our brains to go that far. But computers, they have no problem. Okay, so what's our condition? So so the user types in 20, and where do we store that 20?
No.
In num. Great. Okay, so we have a variable. It has 20 in it, and then what is our condition for the for loop?
No, smaller than 20. I smaller than 20.
I is smaller than. Well, instead of writing 20, what should I write here?
No.
Yeah, exactly. Whenever we can, we want to avoid magic numbers, right? Even if we wanted 20 to be somewhere in the code, we would write a constant somewhere. Okay, so that's our condition. And so then what's this last part?
I plus plus.
Exactly. Okay, and so now if I just, so let's just do this. Cout I. What will this code do here?
Just print I. Until 20.
Right, so what will actually print out? So let's just make this easier. Let's say the user types in 4. What prints out?
1, 2, 3, 4.
You sure?
what is I at the beginning of the loop?
1. I mean 0.
It's 0. So it's going to print out.
0.
And then the second time,
1, 2, 3, 4.
is it going to print out 4?
No.
Right. So these are all shifted. So let's say that let's say that instead I want to print out 1 through 4. There's a few different ways to do this, but what's one way?
I equals 0, smaller than equal to. No.
Okay, so I changed this to what? Equal?
To equal.
Okay, and what else do I change?
I to 1.
Okay. Great. Here we are.
Now the 3, 1. So I'm printing 1, 2, 3, 4.
Fantastic. So now inside of here, how would I know if it's divisible by 3? Maybe I should put this down. So what does divisible by 3 mean?
There's even number divided by 3.
So okay, so let's do this. How do I know that 9 is divisible by 3?
There's no reminder.
Okay, there's no remainder. Okay, so what would I write?
What do you mean?
How do I know that there's no remainder? What can I write in C++ to test whether or not there's no remainder?
If the modulus, right?
Okay,
0.
great. So then instead of 9, maybe we have an I. And that this here is an if condition. And so if this is true, what do we print out?
This.
Right.
It's really no.
Both of them are not quite correct. Check 15 again. Right now, both of your programs print out fizz. If I put it in a fizz. Oh wait, you have a not.
Yeah, not.
Okay. I would encourage you to simplify this. You can avoid having to write all of this.
I put the other thing first.
Yeah, exactly. This covers one case, but you know that if this was false, but one of them is true, that you can cover those, and then. Yeah. So if you move this guy up, you can get rid of all of this. Sorry, when I originally looked at your program, I saw like this was down the bottom. Like, yeah, okay, yeah, 15 is not going to work, but yeah, you got the knots there, so you good. Okay, so right, so we print out fizz in this case, and so then and so we would just say if and then see out fizz, and that's going to go right here, right? So that's just going to go here. So we have our if i's mod 3 equals 0, see out fizz, and then what's going to be the second one?
I modulus 5.
Right.
Equals 0.
Right.
That's it.
And that's it, basically.
I can do like an else, I guess.
Well, okay. So now this is one of the traps that both of them ran into, that I'm going to then direct their attention after we do that to this.
that'll be else, CL I.
Okay.
So put the else if in the second one.
So that's one of the tricks. So that's what they did there. So yeah, let's do that. Let's just do that. Oh, it's my call. So this covers with. So we're good until we hit 15. What happens? What prints out when we hit 15?
Probably print just this.
Fizz, but what should we print out? Yeah. So maybe up here, the first if we have something that covers both of them. If they're both equal, then you print out.
So it's an and statement.
Yeah, and. Also, what you can do is that instead of having this else if here, you can just have them both as ifs, and then you have another if both of them if or this are false, then you print out I. So the idea is that you don't have any else ifs anywhere. You only have ifs. So there's different. There's a lot of different. I think there's 9 different combinations.
But both and the or would be one line. More, right?
It would be 3 lines, which is still 3. This is 4 lines versus 3 lines. If we're talking about efficiency, there's other concerns. But cool. So I think both of these are good now. Cool. Okay, great. All right, success. We can play Fizzbuzz. I found that this is a really good project to do if you're dipping into other languages. Like it's a good gauge. It's a really good gauge to see how people's programming skills are. So, for example, if I'm interviewing someone, this is one of my interview questions. Hey, this random language that you say that you know how to program on your resume, give me a Fizzbuzz. And sometimes, and then I'll give them the rules of Fizzbuzz if they've never played Fizzbuzz. But that's pretty much it. Cool. All right, success. Any questions about Fizzbuzz or about the activity? All right, sweet.
Carter,
Yeah, what's up?
the strangest interview question I was ever asked was at Xerox. Why are manhole covers round? I'm prepared for all kinds of programming questions and stuff like that. And the guy asked me, why are manhole covers round?
They're super strong and the pipes are round.
You gotta think about, give that a little thought. You gotta always-
Oh yeah, derail. Yeah, I mean it's fun to derail people too.
Well, it has to, it's the only geometric shape that won't fall through the hole.
It won't fall through itself.
It can't fall because it's on a circle that's slightly smaller diameter, so you can't get a manhole cover to drop into the hole. But any other shape you can come up with, you can orient it in some fashion where it falls through.
It also evenly distributes its weight. What kind of tree?
Yeah, I was interviewing like an officer for this like Nova High School and high school, and they asked me what kind of tree I would be. I don't even know types of trees. I was just like, I guess an evergreen. And then he asked me why. He asked me why. I didn't have an answer.
So for Monty Python fans, it's a bird, a larch, right? A larch, yeah. There's an entire episode where it's about identifying trees, and they're all the same tree. Cool. Okay, so there we go. We got our Fizzbuzz. Yeah, we've got 9 minutes. Could I just open this up to any other kinds of questions?
Any of you guys that are coming more recently, do you have any questions for viewing for the exam? Any questions for Carter or for me? with the exam coming up tonight? Anything you may have missed on the practice exam? Did you all get perfect on the practice exam or anything?
Make sure you can log into Canvas.
You just did.
No, seriously.
Yeah. I did it several times. I mean, because there's 3 variations in there. So if you do it multiple times, you get different questions. What, did any of you have any trouble with the last one? With that last one?
Okay, everyone, that's it for today online. Hopefully see you in class.
Thank you, Carter.
And stop recording. Stop share. And end meeting. End meeting for all.